This is question 2 of tutorial 3. So the wall OAB of the water container, which is shown, is pivoted about O. We need to determine the moment about O due to the force of the water on this wall. So the information is, say, it is 4 meters long, the container, and it is in the direction into the base. And we have the dimension A is equal to 2 meters, and this B and this C, this is equal to 1 meter. We need to calculate the moment about this point O, due to the waterproof, and this is actually the free surface. So this is the material water. So let's start with this solution. Let me draw the figure at first. So this is the free surface, this is water, this is the wall OAB. So this height, it is given as 2 meters, this is 1 meter. You say this is actually C, and this, so when it is 1 meter, and there is another distance it is given, that means from this pivoted point to this all AV, this distance, this is 1 meter. You see this is given B, so we say it is B, this is C, and this is H. So what we did, we just draw here another, the wall, say OC, the vertical projections. So yeah, we created one vertical projection here, it is OC. And let's consider, you see this OAB, this wall, this is not a straight line. You see it is bending at this point. So it is a bend also, we can say this OAB, this is a curved surface. So this is our assumptions. We assume that this is a curved surface. So now it is very clear that when it is the curved surface, then we need to calculate the horizontal force and the vertical force, right? So let's start with that one now. The horizontal force, you always know that how to calculate the horizontal force. We already solved the first problem, and from the course note from your book, you know what is horizontal force. So I'm not going to explain actually how to calculate the horizontal force, but we created a vertical projection here. So the horizontal force in this case, it will be the force on the vertical projections of this wall OAB. So what is the vertical projections? This is O and C, OC. So that means this is force on OC. Now, if it is the force on AC, we know force equal, we say this is the pressure, rho GH, and the area. So rho density of the corresponding material, so this is water, and the gravity, HC, this is the height from the centroid, and area, how to calculate the area. So here, this is constant 1000, this rho, the density, the gravity constant. So how we got this HC, the height from the centroid? If you see here, the total distance from this point to this point, you see this is 3 meters, right? It is 3 meters. So what will be the centroid? Maybe somewhere like this, maybe like this point. So that means it will be just the 3/2. So this is actually the centroid, and then this height, it should be 3/2. So you see we got 3/2. Actually, you see we wrote it here, the length of this CO, this is 3 meters, so it will be like just half. And the overall length, here, if you look here, the container is 4 meters long. So when we will calculate the area, so that means here actually the length is 4, okay, and this is the width. So we'll get the area if we multiply 3/4. And I believe now you're clear how we got this centroid height from the centroid. So the FH, if we simplify this, we will get it is this value. So this is our horizontal force, right? Okay, so once we have done with this horizontal force calculation F has, so let's calculate the location. So this is actually important, that where is the, we need to calculate the location of this horizontal force. So I believe you know this formula. You have all the derivations in your course note. So we know LCV equal LC plus IC and LCA. So this is the equation we know. And let's say L, it is actually equal H. So if we substitute L equal H, then it should be this HCP. It is LC, that means it is HC. So it should be IC, and this L, it should be HCA. Now the question is how to calculate this IC. For rectangle, when it is rectangle, then IC, it is equal BH cube over 12. So what I will tell you, just go through the books and the course note, see my slide as well. You will see the term IC for different objects like rectangle or triangle or any other domain. So you will see it is different. So substitute this value IC equal BH cube over 12. So put it here. We know the HC, this is 3 over 2. You see, this is 3 over 2. We know the B, the length. So look here in the question. So it is actually 4 meter long, the container. So we know that, and so this is 4, and we have the other one. So you see, this is HC, and this is actually the H. So H is given 3. So this is 2, and this is 1. So this is 3. And again, this is over 12, and then HC equal 3 over 2, and area 3 over 4. We did some calculations for area previously. So we have the HCP, it is 2 meter. So now what is the distance from this horizontal force? So this is the pivot point O. So distance from O to F has, so overall distance it is 3, and we got this distance is 2, so minus 2, so it should be 1 meter, right? So it should be somewhere maybe like this position, the the horizontal, the distance F has. So once we have done with the horizontal force calculations and the location of the corresponding horizontal force, then we should calculate the vertical force. So now we will calculate the vertical force. For vertical force, we know this formula. It is actually the void. So in this case, we have this O, A, B, C, D, this area. So the vertical force, it will act this way. So the vertical force is something, it will work through the down in the upward directions. So we got this area OABCO. So it is acting through this, and definitely from the center. So let's say this is the centroid. So now we know the vertical force, it is equal rho G and the volume. So that means we need to calculate the volume of this OABCD or CO. So we need to calculate the volume of this domain. And if you look here, we have just two things. We got a rectangle, this one, ABCD, and we got a triangle, ABO, right? So we can say that the volume of OABCO, it is equal 4 into area of the rectangle ABCD and the area of the rectangle ADO. So when it is rectangle, you know how to calculate the area. So that means you need to multiply this and this. So this AB and BC. So say AB, BC, and for triangle, so this should be half into, this AD and DO. So you see AD and DO. So now we know all the dimensions here. AB, this is equal to, this is 1, this dimension it is given 1 meter. So definitely this BC, this is also 1 meter. So say this is 1 meter and a half, which is AD. This is given 1 meter. If it is 1 meter, it should be 1 meter. So it is 1. And also the DO, you see, if this distance is 1 meter, it will be also 1 meter because this is the same distance. So this is also 1. And we got it is, when you simplify, you got it is 10 meter cube. And now we need to calculate actually the weight. And this is the rho z and BOB. So this is actually the volume we calculated. So let's say it is 10. So we got 98,000 Newton. So now what we will do, we will calculate the the corresponding distance. So we will actually calculate the distance. So let's say to determine these horizontal locations of the centroid, we'll break this whole domain into two small areas like a rectangle and a triangle. So I will tell you, okay, look at this figure here. Look at this figure here. So we break this one ABCD and ADO. So at first we will draw the centroid. So for this rectangle, this is simple. Maybe if we just divide this way, so then we will get this centroid. You see, this is G1. But for the triangle, what you need to do is to get the right centroid point, you need to just draw a line from this point A on this surface. So we'll just draw a line like this and we'll divide it like this. So we will get this point. This is actually the centroid for this triangle. So let's say this is G2. So for rectangle, if it is the centroid, so say this is the centroid, so this distance it is x1. And when it is the triangle, let's say this is the distance. This distance is x2. So keep in mind, we got the centroid for this area ABCD, this rectangle and this triangle separately. Then what will be the centroid of this whole domain? Let's say this is this is the centroid point for the whole domain. Let me use the other color. So let's say it should be, for the first one it should be somewhere like this, maybe somewhere like this, and maybe it is here. So we say this distance is x. So here we got two different distance. I think let's move to the other figure, maybe this figure. So you can see here, this is the centroid for the rectangle, this is the centroid for the triangle, and let's say this is for the whole domain. So now we will calculate the distance of this x1, x, and x2. So what will be the x1? We said x1 is the centroid of this rectangle. So that means it should be the half of this line BC or CB. So we can say x1 equal half of CB. Centroid, that means it is the just middle of this position. So it should be half of the CB. So CB equal given 1, so it is 0.5. For triangle, we actually know the centroid is like at the one. So if we draw this line, we got this point. So let's say we have another section here. So you see, this is the first part, this is the second, and this is the third part. So that means we can say this is 1/3 of dA. We have the formula, you can go to the books. Just for the understanding, I said it's like that. Yeah, I said this is the second, and this is the second part, this is the third part. So if I get the centroid, maybe this is at the 1/3 position. So it is 1/3 of dA, that means 0.333. So you got x1 and x2, but we actually need x. So now we will calculate the x. So let's calculate the x for this whole domain OABC. DO. So what we can do is we can use this formula. So this centroid into the area of this whole domain, it will be equal to the centroid and the corresponding area, like the axon ABCD plus x2 into IDO. So what I did here is, you see, this is for the rectangle, this domain, and this is for this triangle. So it will be equal for the whole domain. So that's actually, it is true. So why we are doing this? Because we want to calculate this distance, this x, this is unknown. So we know this x1 already, we know the area, we know x2, we know this area, and we also know the area of this whole domain. So as we know everything, then we'll get the value of x from here. So just simplify this on, you need to just divide by this area here. So if you simplify this, then we will get this value 0.467. Now I know you know how to calculate the moment about O due to the water. So this is the horizontal force and the corresponding distance, vertical force and the distance. So if you can remember, we calculated the horizontal force, this 98,000. This is actually the vertical force. Let's see where is the horizontal force here. So we calculated the horizontal force, and then you see we calculated the distance from the pivot point to it was 1 meter. So that means we need this 1 meter when we are going to calculate the moment. So here the horizontal force is 176,400, and the corresponding distance is 1. Right? The vertical force, it is 98,000, and you see the vertical distance, it is 0.467. So that means we got the moment for this problem. So initially so when I explained the question, you see it asked we need to calculate the moment. Yeah, it's the moment about O. So you see here we calculated the moment. We have done with the moment calculation. So what we did, if I just quickly review what I did so far, we just created a projection here like OC. So when it is the projections, we have the rectangle, one triangle, we calculated the vertical force. You see, sorry, we calculated the horizontal force and the corresponding the distance, and then we calculated the vertical force. We just created two separate areas for this whole domain, and then we calculated the centroid of this rectangle, we calculated the centroid of this triangle, and for the centroid for the whole body. And then we calculated the distance x. So once we know the vertical force, once we know the horizontal force, and once we know the distance, then it is easy to calculate the moment, right? So that we actually did, and we got the final solution here is this. So this is the final solution. Hope you understand what I did. If you still have any issue, you can just simply write me. You can come to my office, and then I will just explain how actually I did it. So thanks for watching.